Hi there, Mr. Dunaway here, talking about Chapter 9, Section 5. There is a lot in this section, so be prepared and please stop, write down the questions that you have that you don't understand, bring them back to class. But I'm going to dive right into things. This is going to take me several videos, and this is going to be tested that you can show how to solve using this method called completing the square, which is another way to solve quadratics. Okay, so we can solve quadratics using this method, completing the square. Well, every positive number we've learned has two square roots, and the square root symbol is called a radical sign. That little check mark looking division-like symbol thing is called a radical. And the square roots, an example of 121, well, 11 times 11 is 121, or negative 11 times negative 11. So that's what we mean. Two square roots, that's something we've talked about, and you'll need to know. Perfect square example, 49 is a perfect square because 7 times 7 is 49. And then they define it there, but I do want you to make a note right here. Highlight or underline. This is kind of the key to what's going on in today's lesson, and it gets a little bit strange. And it begins with understanding that a perfect trinomial square means x squared plus 10x plus 25 is the same thing as the quantity x plus 5 squared. Okay, so with that said, if we were going to look at some perfect squares, well, this is a perfect square because 12 the power of 2. So that's yes, it is a perfect square. Or with this one, if you take square root of 49, you get 7 squared. That's yes. However, with number 6, there's no way to take the square root of 8 and get a whole number. It's just the square root of 8, quantity squared. That comes out to a big irrational decimal. That's not a perfect square, and neither is the square root of 6 squared. But the square root of 4, 4 squared is a, whoops, that's not right. That should be 2. Sorry about that. 2 squared. Boy, you guys were ready to jump on that candy, weren't you? That's 2 squared. So that is a perfect square there as well. Again, that's the basis of today's lesson as we talk about completing the square. Now here's where it's going to look a little bit crazy to you. Stay with me. This is a really important part right here. That is that any quadratic equation, I'm reading from this part right here, any quadratic equation can be solved by completing the square. This is the method for today. This method turns every expression such as x squared plus bx, now remember that's ax squared, right, plus bx, but in this lesson in completing the square, you don't need to write that a in there, sorry if you did, that a is 1, a has to be 1 when we complete the square. All right, into a perfect square trinomial. You'll know that there is no c in that, and you'll see why in a little bit. You complete the square, I'm right here now, by adding this value, b divided by 2 squared. You add that value to that part, x squared plus bx, where b is the coefficient of the x term, just like it's always been. It's always been ax squared plus bx plus c. However, in this case, we don't have a c, and a in all of these cases are equal to 1. Well, if we add that term to x squared plus bx, we actually have a perfect trinomial square. You're probably thinking, this doesn't make any sense. Well, it really does. And let me show you an example. This is always true. Maybe something that might make a little more sense to you. Let me try to explain what is going on over here. Consider this trinomial square. I went ahead and figured one out for you. X squared plus 8x plus 16. If you recall from chapter 8, if I asked you to factor that, well, how can I multiply and get 16 and add and get 8? 4 times 4, 16, 4 plus 4 is 8. So this actually factors to x plus 4 times x plus 4. Now remember, that can be rewritten like this, x plus 4 quantity squared. Now since it can be rewritten with that power of 2, that is a perfect square. Trinomial, or perfect trinomial square is what we're actually calling it there. But I want you to get the connection. This is just a perfect square, just like on the previous page. These were all perfect squares, or these two were, and this one was. Okay, it's the same thing. The only thing is the base is a binomial, x plus 4. So when squared, it creates this trinomial here. Now, let's take a look at this one I wrote here. X squared plus 8x plus 16. All right, well, you notice A here is 1, right? That's 1x squared. B is 8. Okay, now consider this. They gave you this part, b divided by 2 squared. Okay, if b is 8, watch what happens if I take 8 divided by 2 and square it. Well, 8 divided by 2 is 4, so 4 squared is 16. It makes this value. Okay, that will always be true in a perfect trinomial square. If you take this term, this coefficient, divided by 2 and square it, you will get the value that makes it a perfect trinomial square. Well, this is really, really handy for us. If we can create trinomial squares, we can solve them real easily. And that's what you're going to see hopefully today. So let's look at number 9 here. It says, use the justifications at the right to find the values of c. So they've given me this right here, x squared plus 20x plus c. They're asking, what is the value of c such that this becomes a perfect trinomial square? Well, we have to use this relationship I just tried to prove, which comes back to this b divided by 2 squared. All right, so we want c to equal that value. So we figure out what b is. Okay, b is 20. So we're going to substitute the value for b. 20 goes there. And we're going to find out what is this value. We're going to divide it by 2 and square it. 20 divided by 2 is 10. 10 squared is 100. All right, so it says use your value of c to show that x squared plus 20x plus c is a perfect trinomial square. So if we take x squared plus 20x, that's what they gave me up here, and we add this number, 100, how do we get 100 again? This divided by 2 squared, that divided by 2 is 10 squared is 100. There it is, that's a perfect trinomial square. Why? Because now if we were to factor this, that would factor to x plus 10. Notice that's the square root of that value. Times x plus 10, that's how that would factor, which is equal to x plus 10 squared. Okay, so that is now, you can see the perfect trinomial square written in both forms, like that. All right, so this piece is really important. You're going to have to memorize that it's b divided by 2, that quantity squared, to create a perfect trinomial square. Okay, and this is really important to us and really valuable for us. It's something, as far as a reason why, hopefully you'll see by the end of my last video here. All right, so let's move on to the page that I made. I'm going to just work through some examples here and hopefully help you see, first of all, how to do it, and then at the very end, why it's incredibly valuable for us, that we'll see shortly. Okay, here ends video 1, and prepare for video